They say the cosmic microwave background radiation is the echo of the Big Bang. But if that's true, then what sound does the birth of a star make? You might hear a hiss, the noise of its solar wind pushing against the silent darkness. Forever expanding, forever pushing. This bubble of solar wind is called the Heliosphere. It's about 120 times the diameter of Earth, and it surrounds our little blue dot, protecting us from harmful cosmic rays. Now, for decades, we thought this bubble looked like a comet's tail, pointed and long, streaming out behind Earth as it flies through the solar system. But NASA just dropped a bombshell. Our heliosphere doesn't look like a tail at all. It looks like a croissant. And this discovery could help scientists searching for life beyond our solar system understand just how rare Earth is. Here with Minute Earth. First, let's talk about that comet tail model. Our sun constantly blasts out a stream of charged particles called the solar wind. These particles flow out from the sun, and they carry a magnetic field with them. When that magnetic field is carried far out into space, it forms a bubble that shelters anything in its path from dangerous cosmic rays. That's the basic idea behind the heliosphere. A protective bubble of solar wind that extends as far as 120 astronomical units from the sun. To put that distance into perspective, Pluto is only 40 astronomical units from the sun. But when NASA launched the Voyager space probes in the late 1970s, equipped with instruments to measure the solar wind, they found something weird. The bubble wasn't pointy, it was kind of spherical, almost like a pancake. Scientists realized that something was throwing the solar wind into this funky shape, but they didn't know what. To solve the mystery, NASA sent out a couple of interstellar detectives, the Interstellar Boundary Explorer, or IBEX, which launched in 2008, and the Voyager probes, which have been wandering the outer solar system since the 70s. IBEX found that the solar wind was being deflected by a thin ribbon of gas and dust called the local bubble. As for Voyager, well, it finally reached the edge of the bubble in 2012, confirming that the heliosphere was indeed shaped like a pancake. But what's giving the solar wind such a peculiar shape? Turns out it's pickup ions. Those are atoms that have been stripped of some of their electrons and become electrically charged. Most of these ions come from the sun. They travel on the solar wind and get flung into the interstellar medium, where they can interact with stuff like dust and gas. Other pickup ions come from the interstellar medium itself. When the solar wind hits it, it can blast dust and gas off of nearby comets and other icy bodies. When these pickup ions enter the solar system, they don't just move along with the solar wind. They do a little dance. They jiggle back and forth between the sun and the interstellar medium, and they bring a magnetic field with them. All these bouncing pickup ions with their own magnetic fields act like tiny little bar magnets. And together, they form a huge magnetic field that extends far out from the sun. Here's where things get really cool. Just like a bar magnet, this magnetic field has a north and a south. And just like a bar magnet, you can't see it without iron filings. The interstellar medium doesn't conduct electricity, so the magnetic field lines of the heliosphere are invisible. But scientists can detect the movement of charged particles. By following those paths, they can map the magnetic field and get an idea of what the heliosphere looks like. And it turns out the magnetic field lines form a flattened, croissant-shaped blob that extends 100 to 120 astronomical units from the sun before it disappears into the local bubble. The reason it's shaped like a croissant, or more technically a crescent, is because the sun's not the only thing moving. Earth is also orbiting around it, and that motion has an effect on the pickup ions. When the sun is closer to the galactic center, Earth moves faster, and that causes the crescent to flatten. Okay, but why does any of this matter? The shape of our heliospheric shield determines how much of this harmful space radiation reaches Earth, and that amount can be huge. During solar maximum, the sun blasts out a particle every second. So it's important for satellites, astronauts, and even climate models that try to simulate the effects of cosmic rays on our weather and climate. But the shape of the heliosphere also tells us something else. It gives us clues about the protective bubbles around other star systems, and whether or not those bubbles might be able to support life. Because the strength of the magnetic field a star produces depends on its size, Stars with larger, more powerful magnetic fields will have heliospheres that are harder for cosmic rays to penetrate. And that means planets orbiting those stars will receive less radiation. So the next time you look up at the night sky, remember that the magnetic fields of distant stars may be doing the same thing our sun's doing. It's protecting their planets from harmful radiation and making them habitable. Think about it. Our sun isn't just warming our planet. It's wrapped us in a cosmic shield shaped like a croissant. That shape tells us how life survives among the stars. And because of it, Earth is habitable today. That, my friends, is the kind of cosmic engineering that humanity needs to understand to protect our future.